See in 100 seconds. Hash table implementation. Last episode, collisions overwrote values. This time we fix that with chaining. Each bucket holds a linked list. Watch the entry struct on line 7, key, value, and a next pointer. See line 13. The table is now an array of entry pointers, not strings. Each bucket starts as NUL. When two keys hash to the same index, they chain together through next. Watch insert on line 21. See lines 26 and 27. We set E arrow next to whatever is already at that bucket, then put E at the front. New entries prepend to the chain. See how insert always prepends? Even if the bucket is empty, it works because NUL becomes the next pointer. No special case for the first entry. Watch Lookup on line 30. See the while loop. It walks the chain at that bucket, comparing each key with *CMP. When it finds a match, it returns the value. If the chain ends, it returns -1. See delete on line 40. Watch the previous pointer tracking. When we find the target, we check if previous is NUL to know if it is the first in the chain. Then we rewire and free, just like deleting from a linked list. Watch print table on line 56. See the nested while loop. For each bucket, it walks the chain printing each entry with an arrow. Empty buckets just show the index. See main. We insert Alice at 90, Bob at 85, Carol at 92, Eve at 88. Alice and Eve both hash to bucket 8, but now they chain instead of overwriting. See the output. Bucket 8 has Eve arrow Alice, both preserved. Lookup Alice returns 90. Eve returns 88. Zoe returns -1. After deleting Alice, bucket 8 has only Eve. Chaining solves collisions. Next up, binary trees.